All right, this is the pre-video for section 5.2 and 5.3. This is going to be a little lengthier than normal because this is the day that I will have the sub, so I'm doing a little more than normal just so that you guys get a well-rounded lesson. So we're going to be looking at 5.2, which is integration by substitution. This is for functions whose derivative would likely use a chain rule if we were doing the derivative originally. So the antiderivative typically will involve what's called a substitution, and we call it U-Substitution just because we use U as our variable. And we can completely rewrite the integral in terms of what's called U and du. U is the inside, or the inside of the composition part. So like here in this first one would be the x squared plus 1 because that's being raised to the 4th power, so that's an inside function. And then du dx is f prime of x, which means du is f prime of x dx. So it's the derivative of your inside function times the dx. So we're going to look at this first one and just kind of get an idea of how this would work. So you would set u equal to the inside function, which is x squared plus 1. To find du, you take a derivative of this, so that would be 2x, and since this is the wrong variable, here's our dx. So notice the du dx is kind of, we're taking the derivative with respect to x, but instead of writing the dx over here, we're multiplying it to the other side. And then so we do our substitution once we get this. Now we have to make sure that our problem actually is set up to do substitution. So what we have is that we would let this equal u to the 4th, and then notice 2x dx is this, so that is just du. Then we would take the integration using our general power rule. So we add 1 to the exponent and divide by that new number, and we have our constant of integration. And then we do what's called back substituting. So then this would be x squared plus 1 to the 5th over 5 plus c. So that's how this is going to work. We'll do some variety so you can see some different versions of these. So I'm going to be doing the odds in section 5.2. So our guidelines for integration by substitution, which again doesn't always work, but if it has the correct setup, it's a good way to do your integration. You let u be a function of x, usually the inside function. Solve for x and dx in terms of u and du. Convert the entire integral to a u variable form. After integrating, we write the antiderivative back as a function of x, and you can check your answer by taking the derivative if you want to. So let's look at this first one here. So number 1. Now looking at this, it's a very complicated product right here of a function times a radical function. So since that's not something we know how to do with integration in this class, we're going to let u equal that inside function, which is x to the 3rd minus 4. Then du, or du dx, if you want to then move the dx over afterwards, is 3x squared times dx. Now, I usually regroup this so I can see if this matches. This is the integral of the square root of x to the 3rd minus 4 times a 3x squared dx. That's what we have in our original problem. So as long as I see the 3x squared dx, I know that this is ready to go. So this is going to be square root of u and then times du. Now square root of u can be rewritten as u to the 1/2. And then we're going to use our general power rule here, which is going to be u to the add 1 to the power, so that'd be 3/2. And then you divide by that number. So if you divide by that 3/2, you're actually multiplying by 2/3. And then we'd have our plus c for our constant of integration. And then the only thing left we have to do here is to put the x to the 3rd minus 4 back in for our u. So this is 2 times x to the 3rd minus 4 to the 3/2 all over 3 plus c. So there's my first problem. Let's look at number 3 together. So the inside function for number 3 is going to be the 3 minus 5t squared because that's inside that cubed part. So we're going to let that be our u for our u substitution. 3 minus 5t squared. Then I take the derivative of that, and that's going to be negative 10t, and then this would be times dt. So then I'm going to regroup what I have, and notice this time I don't have an exact match, but we can manipulate our statement right here to make it match, and I'll show you how we can do that. Now the only way we can manipulate it is if everything is a number. If you have something that is an extra variable, or you're missing a variable and you need one, sometimes you can't do what you need to do. So But as long as you just need a number, then we can fix it. So notice I have a t dt, but I don't have a negative 10. So the way we fix this is we want to make it match this. So I'm going to divide this by negative 10. So what we now know is that du divided by negative 10 is t dt. So when I do my substitution, I'm going to have a u to the third times a du divided by negative 10. Now we don't like having an extra coefficient in here, so we just bring that out to the front because coefficients can be brought to the front of our integration. So it's negative 1/10 when we pull it out, u to the third du. So this is negative 1/10, and then this would be u to the fourth divided by 4 plus c. And then remember, we multiply this together. So that's going to be negative u to the fourth over 40 plus c. Don't forget to do our back substitution step. So this is going to be a negative 3 minus 5t squared in parentheses to the fourth all over 40 plus c. Now, if we're not sure if we've done something correctly, you can take the derivative of this and see that it goes back to the original function. You'd pull your 4 to the front. That would reduce that down to a 10, and that would be a negative 10 in the denominator. That would now be a cubed, and then we would have to chain the inside, which is a negative 10 t. So then that would make the negative 10s cancel, and you'd still have your t. So it actually does go back to the derivative. When you take the derivative of this antiderivative, it goes back to the inside function of the integration. All right, so we're going to do number 5 and 7 and 9. So let's look at 5. This one, again, we're going to look at what's going on here. If I try to do this one by U-substitution, I would let u equal the 3x to the fourth plus 1. Then du would equal 12x to the third dx. Now, this is where we're in trouble, okay? Because if I rearrange this, squared, and then I have a 2 dx, we have an x here, there's no x here. You cannot add x's in. You can do stuff like multiply by numbers, but you cannot add extra x's or variables. Okay, so we cannot do by the U-substitution method. So what we're going to do instead is we're just going to FOIL this out. So this would be, let's see, 3x to the fourth plus 1 times 3x to the fourth plus 1. So I'm going to have, and then all of this is times 2. So instead of trying to do a trick here, I'm just going to see if I can turn this into a polynomial. So this will be, let's see, 9x to the 8th times 2, so that'd be 18x to the 8th. Then I have a 3x to the fourth plus another 3x to the fourth, so that's 6x to the fourth times 2 would be 12x to the fourth. And then 1 times 1 is 1, times a 2 is 2. And then we're just going to treat this as a general power rule with 3 terms. So we add 1 to the power, so this would be 18x to the 9 divided by 9, plus 12x to the 5th divided by 5, plus 2x plus c. And then I'm going to reduce, so this is 2x to the 9th plus 12/5 x to the 5th plus 2x plus c. So just because integration by substitution exists, it doesn't mean it's going to work. And that's because if you can add, like I said, you can multiply or divide and make a number appear on your dx part, but you can't just throw in extra x's that we would be missing. So, you can't always make it the way you want it to. So if that happens, try a different method. All right, so let's look at number 7. This U-substitution that we're going to try for this one. We're going to let the bottom part has that cubed in it. So we're going to see if we can let the inside of that parentheses be our u. So this would say u is 7 plus x squared. So du is 2x dx. Let's regroup what we have. So sometimes I'll write this just as 1 over that, just to separate it out. And then bring the 6x out to the side, so times 6x dx. Okay, so this is fine. This will be 1 over u cubed, but this is 6x dx, and I only have 2x dx down here. So instead of dividing, I can actually triple both sides. And this is still valid because that is legal to do in an equation. You can multiply both sides by the number 3. So we're going to be replacing 6x dx with 3 du. So this would be 1 over u to the third times 3 du. I would pull my 3 out to the front and maybe bring my u to the negative third up now since I want to make it so I can use my rule. I add 1 to the power, which makes it u to the negative 2. Divide by that. We have our times 3 out front, plus our c. So this guy would be, let's see, a negative 3 over 2, and then this u squared is going to the bottom, and u is 7 plus x squared plus c. So there's my answer to that one. And then the last one for 5.2 is going to be number 9. This is just the same application we've done every time we've taught you about kind of, working through a problem. We then write an equation of some kind. Usually it's been the equation of the tangent, but this is different because we're going backwards. So it says find an equation of a function that has the given derivative and whose graph passes through the given point. Okay, so every time we've been doing integration, we've been writing this plus c because we didn't know the exact family or out of the family of functions that all have the same derivative, we didn't know which one we were talking about. If someone gives you an actual ordered pair, then they are going to give you the tools to find an exact equation instead of just the family of equations. So that's something really nice. So let's talk about how to set this up. The first thing I would realize is that the original function we're going to call big F. Remember, that's for the family of functions that all have the same derivative. We know that big F of 2 equals 10. That's a fact that we know from that ordered pair. We also know that when you take an antiderivative or integration, big F of x is the family of functions that have that little f prime of x as its derivative. So we're going to plug in our function here. So big F of x is equal to the integral of 2x times 4x squared minus 10 squared. We're going to try to do a U-substitution here. So u equals 4x squared, and that's a dx. Sorry, I left off my dx. Minus 10 du would be 8x dx. So let's regroup this a little bit. So big F of x is the integral of 4x squared minus 10 to the second times a 2x dx. This helps me figure out how I need to change this. I've got 8x dx. I need a 2x dx, so I'm going to divide both sides by 4. So this makes du over 4 is equal to 2x dx. And that will fit my substitution. So big F of x equals the integral of u to the second times du over 4. We can pull our 1/4 to the front of the integral. And then we're going to integrate this. So this says big F of x is equal to 1/4 times u to the third over 3 plus c. So this is just doing our indefinite integral just like we've done this whole time. So that's u to the third over 12 plus c. But now we know f of 2 equals 10 for our big function. So f of 2, which means we're plugging, oh, sorry, I haven't substituted back in. Let's fix that first. So f of x, because we need it to be in terms of our x, not our u, is, remember, what was our x? 4x squared minus 10 to the third over 12 plus c. There we go. Now we're going to plug in 2 for all of our x's. So big F of x, which we're going to call f of 2 this time. So f of 2 equals 4 times 2 squared minus 10 all cubed over 12 plus c. We're going to be able to solve for c. So f of 2 we know is 10, and then this side we're just working this out. So that is, let's see, that is 4 times 4, which is 16, minus 10, which would be 6. And then we would have 6 to the third over 12. So I'm going to write that plus c. And then 6 to the third divided by 12 comes out to 18. I worked that out on my calculator. So c is negative 8. So what this means is that the exact or particular equation that is going to have the derivative we stated and pass through the point that they gave us is big F of x equals the original part we got right here, which was the 4x squared minus 10 to the third over 12. But the constant of integration here is a minus 8. So notice this is not just saying any constant, this is the particular constant that would work. Okay, so that is the end of the pre-video part for 5.2. Our next part is going to be 5.3. And I will do that on a separate video so that it doesn't end up causing you guys to watch too long of a video at the same time.